Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Heterogeneous Programming with OneAPI. On today's show, we have James Reinders, Evangelist for OneAPI at Intel. Welcome, James, to the show.
Happy to be here.
And for those of you, I cut like 3 or 4 times already off because I couldn't say James Reinders correctly, but now I did. I finally got it, James.
You did indeed.
So, James, tell me first a little bit about yourself and why you're considered a evangelist for OneAPI.
Well, I'm a software programmer who loves computer architecture and loves getting down and dirty with programming to make the best activity, the best performance, take the best use of hardware in my software. So I love what OneAPI is up to in light of the new heterogeneous computing that's happening to us.
So I'm a software programmer too. I don't know if you knew that, James, but I go from the top down. I always called you guys that dealt with the hardware like bit heads, right? Because you're sitting down there. How can I get the most cycles out of every single instruction that I do, right? And that's where you're at, right? You like being down in that level?
Absolutely. Right down at the assembly level, working inside compilers, inside libraries, trying to connect the rest of the world to the performance the hardware is capable of.
All right. So we got one of the brightest guys, obviously, because if you're dealing at that level, you got to understand hardware. You got to understand all that. So, but doesn't OneAPI kind of take you a little bit away from that? Just a little bit?
Well, that's the objective, is for OneAPI to help abstract the enormous diversity that's coming in hardware so that we can take advantage of it higher up in the stack and get the most out of our hardware. But those of us working on OneAPI get really close to the hardware stuff.
Oh, that's true. So here's a question. When you said heterogeneous, are you talking just GPUs and CPUs? Because those are heterogeneous, but is that what it's geared towards? Is OneAPI geared towards just that?
Well, it's more than that, but you've got the right idea. The word heterogeneous basically means that you've got different devices in a system that can do computation, but they don't run the same instruction set. So, a CPU has a way of running instructions, a GPU has a different way, an FPGA, other ASICs, specialty devices for AI, whatever you may have different ways of being programmed. And we'd like to take advantage of all of those. And one of the big trends in the industry today is that machines are getting more and more heterogeneous.
Yeah, I've noticed that myself with some of my federal customers, right? I mean, I want a purpose-built machine, right, to do something very specific. They typically go down the route of an FPGA first, and then they move into EASICs and things like that. But the big obstacle for FPGAs is the programming model is hard.
Absolutely. Hennessy and Patterson, who are leading in the computer architecture field, have called this the new golden age of computer architecture. Gosh, if you're a computer architect, this is an amazing time. You get to design all sorts of specialty devices to do better things for specific domains. But gosh, if you're a software programmer, when I hear architects getting excited, I want to run away and hide. It's the opposite of exciting. It's scary, because the question is, how the heck do I program this? And that's really what we're after with the OneAPI initiative and OneAPI products.
So tell me a little bit about, is OneAPI a product from Intel? Tell me how it came about and what's its main community or purpose?
Yeah, one of the first things that's a little confusing about the OneAPI name is it's both an initiative with a specification and an implementation. The initiative has a simple concept. I want to be able to, from my software, have the freedom to use any device I want. I want to get the value out of that device, the performance. I don't want to just use it. And I want, to have some concept that my coding preserves its value, that, I'm not rewriting it every time a new device comes along. So these three qualities are important, and they can be applied to compilers, to libraries, to debuggers, to any type of tool. That's what the OneAPI specification is about. And it's a pretty broad specification, but it aims to say, hey, here's a way to approach particular problems, whether they be C++ or they be a debugger or whatever, or math library. Here's how we approach them to give us those qualities. But you know what? A specification is a specification. Then the question is anyone implementing it? So fortunately, a great deal of the software to do this has been open sourced. A lot of it originated from Intel. But then Intel also takes that and makes it available as downloadable toolkits that are already pre-built and ready to go to support Intel hardware. And we see other vendors creating parts of OneAPI have their own implementations. So we come together on specification, but we each get to create support for our own hardware in an open multi-vendor fashion.
So if I'm a higher level programmer like I am, right? Let's say that I have an algorithm that does, I don't know, object detection or something like that. I can write my algorithm once and then use API or OneAPI to then target it to different hardware. Is that kind of the goal?
That's the high level goal, but I want to be careful because there's always this idea, gee, can I just write it once and it runs great everywhere? It's a complicated problem, but yes, the objective is to give you a way to write it that ports easily, doesn't require hardly any effort, and that the performance tuning is available regardless of what hardware you're on. So hopefully, if you get it working well on a GPU, it'll run on most any GPU similarly. If you want to switch your algorithm and run on an FPGA, I'd like to maximize how much of your program you reuse, but give you the option to recode parts of your algorithm if you want for, say, an FPGA or a TPU or some other ASIC. I want to give you the flexibility as a programmer. I don't want it to trap you at saying, you wrote it once and it runs everywhere, but not well. Instead, it's a little bit more complex approach that gives us an ability to take advantage of any hardware with varying degrees of rewrite, but hopefully very isolated rewrites.
So like, for example, like you said, if there's a TPU in there, right, I could then say, hey, this part of my algorithm can take advantage of a TPU, pragma that or something. I'm guessing I can then isolate that and target that for a TPU, but in general, it'll run on my CPU fine. On the TPU, it'll run even better. Is that the concept?
That's roughly the concept, but it's even more exciting than that because pragmas or if-defs tend to mean that you're building one code for different devices. We've even got more sophisticated runtime approaches that allow you to detect what's there and run different pieces of code so you can actually have a common binary, a common source code that dynamically decides. That way you can deploy a program and it can figure out what's on your machine and use it dynamically rather than tell the user to run a different binary depending on what machine you're on.
All right, so now I'm going to take that concept that you just, because that's super cool. Right, I could have one binary, which means I could have one container image.
Absolutely.
That I could then deploy in my data center on the edge where I have an ASIC running or an FPGA out on the edge in a smart camera or a sensor or whatever, or my smart city. So I thought with OneAPI I did different compiles, but this is even better than I thought, right? Because I can optimize my code for the different types of machine all in one binary, drop that container wherever it is, detects what's running or what's available hardware, and then runs that piece of code. That's pretty slick.
Oh, it is. It's extremely exciting. And it highlights a key reason that we need to have the sort of discussions that OneAPI brings forward. For a long time, whatever computer I wanted to run on, I could get a software stack, a compiler, debugger, so forth from the vendor, use it, and it ran. And I didn't care that much about the exact software stack. I just used whichever one was best for my machine. But nowadays, I really want to compile a program that may use devices from multiple vendors. I may my program may come up running and there's an Intel CPU sitting there and a GPU from AMD, or I'm running on an ARM processor, but it has an Intel GPU hooked to it, or any of these things. I want my program to be able to react to that. And in order for that to work, the compiler has to be able to spit out code for these various devices in a reliable fashion. And this is where openness really comes to play. You get into something like the LLVM open source project and you do the right things with it, it can produce code for multiple modules. So it really is a great application for open to get to this multi-vendor stance rather than some closed proprietary systems that seek to only support one vendor.
Right. So that brings up another interesting point. A lot of times people will argue that, hey, if I do have a closed system, then I can even get better performance because I've tuned my libraries or my language specific to the hardware capabilities that are there. That argument's always going to be there, right?
Yes, and the question is, what can we do to get the best of both worlds? So you don't want your open system to not allow you to call some closed system parts. Like, so if you're using a math library, if it turns out there's a vendor specific implementation, we should be able to get access to that at runtime to take advantage of whatever optimization that vendor has done. But we want to do it in an open, portable enough manner that each vendor knows what they can implement so that it's consistent. And as a software developer, I can call a library and there may be vendor specific parts sitting behind it, but I have a common program. That's really a big part of OneAPI. It isn't trying to reinvent the entire world. It's trying to organize it in a way that can take advantage of the best on every platform that's possible.
So that makes it much easier for me as a software engineer, right, to program. I don't necessarily need to know all of the idiosyncrasies of all of the different devices that I might be programming with.
Absolutely.
I can rely on a library.
Right. And this isn't to say that when you get down and you figure out that there's a part of your program you really want to optimize, you may dig in, depending on your level of interest on that part. But we really can minimize how much is different in our applications or how many different tools I have to learn. Let's leave the differences to where they really matter rather than where they're just arbitrarily getting in my way of my code porting.
No, I hear you there. Now, another question I have about this, I think other people might be asking. So with one binary, I can now talk to multiple devices with OneAPI.
Yes.
So it's handling moving memory, moving data, all that for me as well.
Yeah, well, yes, it has all the capabilities of doing that.
Got it.
And so then the question is, there are different programming models that might sit on top of OneAPI. That you could have SYCL, which uses C++ constructs and has the concept of either unified shared memory or buffers. You could be using OpenMP with Fortran and C, and it has a concept of targets and different ways of moving memory. There are many different systems that may interact with OneAPI, and it's really your choice of how much you want to get involved at managing the memory. And any programmer of a heterogeneous system can tell you that moving data around is
expensive.
It's expensive. It consumes power. You have to hide it with computation. So you can't escape that. But giving you the tools to manage that, to query the system and let your program at runtime make the right decisions that'll get you the best performance is really important.
So that's another thing that you kind of alluded to. There's a lot of dynamicism. Is that a word? Dynamicism.
Sounds good to me.
It sounds like a good word. There's a lot of dynamicism in capabilities in the programming model, right? I can make decisions at runtime on you said memory models, probably targeted hardware. Does it give me some telemetry back? For example, this is just a crazy example. I don't know if it's real. Maybe my GPU is already working pretty heavily, and I can determine that. And instead of targeting my GPU to do something, I can target something else. I can just keep running on the CPU, for example. So does it give me that kind of where I can maybe even do some scheduling myself or not?
The answer is yes and no. So what you're talking about can be looked at different levels. So if my application itself has a lot of work to do, it certainly gives me enough mechanisms to balance. If I've got a lot of computation, I might do some of it on the GPU, some on the CPU, some on an FPGA. I can do the dynamic balancing in my application and decide that I've busied the resource.
Okay.
But if there's other software on the system, that's still an area that's, I think, future work, future discussions, not only for OneAPI, but the whole industry in terms of how much telemetry do you want to be able to get back from the operating system about what other users are doing. And
yeah, that's a security problem too.
it could be. So then the question becomes, when do you, who gets to know that? Who gets to cooperate? Does who throttles you? Yes, there are security concerns, and that's a much larger topic, but it's one that's a very real topic. HPC environments solve this problem by giving applications dedicated uses of nodes, right, and then balancing by either putting an application on nodes or not. Systems in the cloud often virtualize an environment, but they try to make sure that they're allocating those virtual environments where there's available resources. So it's an interesting question. Where in the stack do you do that balancing? But there are definitely mechanisms at OneAPI level to let the application do the things that we're comfortable letting it do. And yes, and then
I guess we don't want to write a scheduler in every program that we write. That takes me back to the day I wrote my own OS, right? We all had to do it in college.
Absolutely.
Yeah, it was a bear. All right, so my next question is, with OneAPI as well, there's open source libraries that are out there. You can also buy support from Intel, I'm assuming. I'm also guessing, and I don't know, help me, there are tools that help me do tuning and migration and things like that available too?
Oh, absolutely. So one of the things about Intel's implementations are that Intel's got decades of experience building these sorts of tools. Tools like the Intel compilers have been well known at being highly optimizing compilers. The vTune has been around a long time, has hardware support to go with it. Has helped evolve the industry around hardware counters on processors becoming the norm. There's other analysis tools we have as well to give you feedback on the structure of your program. So all of those have been around for a while, and Intel is applying those and making them available in a OneAPI fashion to be more versatile than just being all about a CPU. So those are available. There are tools to help if you're looking at migrating CUDA code to SYCL, so that you could target more devices than just NVIDIA GPUs. That can give you great feedback. There's tools to give you advice about how well parallelized your code is or whether offloading it is productive, because what you were talking about with data movement, we've got tools that can help model that and give you a little bit of feedback about whether it's worthwhile to offload something, give you feedback, how you might want to structure your program. And all of these tools come together and can be quite helpful. There's also tools to help look for deadlock and race conditions in parallel applications. Even if they aren't causing you a problem, It can analyze your program and tell you where perhaps you need to add some locks or change the way that you're taking locks, give you some advice on that. And I'll tell you what, anything that can help me get rid of a bug before it causes me to pull my hair out and spend a week on it is highly valuable. And those things are all part of the OneAPI tool suite.
Great. So where does we can just go to the Intel website and find this information? Where can they find this information?
Absolutely. One place, simple place to start is you can go to the oneapi.io website and learn about the initiative and click the implementation tab, and there'll be a link there to follow to go find the Intel implementations, which are right now the most comprehensive of the implementations, but you can learn about some of the other up and coming implementations as well. But you click on the Intel implementation, you can download the different toolkits. You may also find some references to DevCloud, which is a service that Intel provides to go try the tools out in the cloud. Just search for Intel DevCloud and find that, and you can sign up for free and try the tools in the cloud for free as well, including on different hardware like FPGAs and GPUs and CPUs, even if you want to do that instead of setting up your own machine.
Well, so that's pretty cool. I can program an FPGA through DevCloud.
Absolutely, and I think it's a great way to do it.
that's a lot better than putting it in my lab at home, right?
Especially unless you need some extra heat and noise in your room.
Yeah, I was going to say, yeah.
So these are big systems.
Yeah, so that's pretty cool. So DevCloud. Also, are there any training videos or anything out there? I'm sure the community is already starting to really kick off around this.
Oh, absolutely. And I think some of our best training content is revolves around DevCloud, because not only does it, someone speak to you and talk about how you can try different things in the sample codes, but you can actually go try it out. And some of the training uses Jupyter notebooks to give you a step-by-step, but you can always open up a terminal window and take full control yourself. So yes, the OneAPI website has quite a few different tutorials, depending on what you're interested in, ranging from hands-on tutorials to YouTube videos, and talking about how to get the best performance using OpenMP or SYCL, or on AI algorithms, how to get the best performance. You'll find tutorials on all of the above. A little bit of Googling for it, and you'll come up with it pretty quickly, or again, start at the OneAPI website and click through things, and you'll find a very large number of resources available.
So how's adoption coming with this? Who do you think is the first? What are the first groups that are adopting OneAPI? Are you seeing it mostly in HPC? Because most HPC guys are used to parallel programming, right?
Well, HPC is definitely a hotbed for OneAPI right now. And if you think about it, it's a logical place to see a lot of interest in this, because HPC is all about building and using the biggest, baddest computers in the world, right?
Yeah, exactly.
And so, there's a real feeling that you should be able to use whatever innovation there is. And, over the decades, we've seen a lot of innovation in HPC. And with this explosion of new computer architecture ideas, I think we'll see even more diversity. And I can tell you there's already enough diversity in HPC that people with really large codes, and any compute center is going to have a lot of large codes, ones that do molecular dynamics or crash simulations, or the list goes on and on and on, things that can help solve the biggest engineering problems in the world, or help us solve pharmaceutical problems and evaluate new drugs. There's just an amazing assortment of codes that are very important. And of course, they want to run on the latest and greatest hardware. So this concept of performance portability is really getting in front of people, and the national labs and the universities and the research centers and the industrial users that use these big, expensive, very capable computers, they want their programs to move between them. They don't want to get locked in. And, you periodically get some degree of lock-in because you get a new hot computer capability, but then you really say, gee, I want to be able to move and use new
Yeah, but
innovations.
2 years from now, that hot computer commodity is, a heater in the basement of a building. Right?
Absolutely, if it's still plugged in, and then when you unplug it, it's a paperweight. Yeah, I've designed some of those paperweights, and they were the fastest things in the world when we deployed them. But absolutely, and I want the code lasts much longer.
Right,
So
right.
OneAPI is a huge conversation, a huge part of that. But this doesn't just affect HPC. We see, lots of important codes. I mean, let's face it, today's HPC is tomorrow's department server is, a little later than that, it's our laptop and then our cell phone in terms of compute power. So the capability to use this different hardware, it affects us all. And a little bit of planning ahead and paying attention to how portable and performance portable you're making the code that you depend upon is really important, because code doesn't die quickly. It lasts for decades. And I can promise you, within a decade, heterogeneous systems will reach out and touch all of us. And, you'll be looking back and saying, gosh, I wish I had paid more attention to this. So the time is now to get educated about it and think about it. And there's a lot of opportunity just to nudge things in the right direction.
Now, I don't have to, I like what you said there, because we should be learning this now. It doesn't mean I have to be a parallel programmer to take advantage of OneAPI, right?
No, not at all. It's about looking for something that's open and multi-vendor, multi-architecture capable. And depending on where you are in the software stack will dictate how much you want to know about parallel programming or the gory details. But you can, even if you're way at the top of the stack, you should at least understand what the stack is that you're sitting on top of and what it's capable of in terms of portability and performance portability.
Well, and I'm thinking IoT. As we start seeing more capabilities in IoT and we have more heterogeneous compute on the edge, I know it's really, really difficult to write programs in the IoT space, because I may not have all the different variety of devices. And so I want to write it in one place, but to deploy it across multiple different places. So this could be an interesting way to have one program that can run across multiple different heterogeneous compute devices in a very complex mesh of sensors and edge devices and gateways and all this stuff that's out there. So I see a whole nother area besides massively parallel computing and super fast. I also want super portable.
Absolutely. And, we did talk about HPC a bit, but the embedded community, the IoT community actually has been way ahead on this. That, you look at the average design of a cell phone alone or any IoT device, and they do tend to have multiple compute units, and they use all sorts of methods to manage them and so forth. So and of course, their compute power, their compute capabilities continue to rise as technology moves on. So the everything we're talking about with OneAPI applies there, and to some extent helps formalize or standardize things that in a lot of cases have been innovated first in the embedded world. The embedded world's been more heterogeneous than any other part of the compute industry for a longer period of time.
Oh, because they had to be, right? Yeah.
They felt the pains of power. Running on a battery really makes you power conscious, and the rest of the world's looking at these domain-specific devices and things, even just GPUs, looking for more power advantage when they're doing their massive computations. But if you were running on a battery, you've been thinking about that even longer.
Yeah. Well, hey, James, this has been wonderful. OneAPI has grown up quite a bit over the last couple of years. I'm seeing even more. My brain's like going, oh, I want to try this. I want to try that now. So great news on OneAPI and how it's moving forward. So thank you for coming on the show today.
Oh, it's been my pleasure. And I've been enjoying the growth as well, moving from this OneAPI is this crazy idea a few people are talking about to now more and more people saying, oh, that makes sense. It solves a problem that I need in my organization and I want to learn more.
All right. Thanks again, James.
My pleasure.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.